Question 1 in exercise 3b. A particle is projected with speed 7√5 meters per second at an angle alpha, where tan alpha is equal to a half, from a point on a horizontal plane. Find 1, its initial velocity in terms of I and j, and secondly the horizontal range. So anytime you're given the tan, and we know sine and cos are in the initial velocities, tan is opposite over adjacent, this 1 over 2, so you guys know already this is √5. So write down your cos A and your sine A. Cos A is adjacent over hypotenuse, and sine A is opposite over hypotenuse. So we have our speed. So the initial velocity is equal to u cos alpha times I plus u sine alpha times j, and then just fill in your values and we'll have the answer here. So 7√5 by the cos of alpha, which is 2 over √5 times I, and we have in the j direction u sine alpha, which is 7√5 by 1 over √5 times j. Now clearly the √5's cancel and we're left with the velocity vector being 7 2's are 14i plus just 7j, 7 times 1. For part 2, the horizontal range, we obviously need our displacement in x, but to get displacement in x we need the time taken to get from the start to the finish. So s of y is equal to 0. We know at these 2 points, here and here. So s of y, displacement in y, I think it's good maths to write the formula out until you get sick of writing them out and you know them off by heart and you're never going to make a mistake. So s is equal to ut plus a half at squared. So the displacement in y is my 7 times t, and we know a half a is 4.9 or minus 4.9 t squared. So this would have to be equal to 0. So can I take 4.9 out of here and make it work out evenly? I think it does. So the other thing to do is just to take t out and write 7 minus 4.9 t inside the bracket if you don't want to take the 4.9 out, and then you can say that this is my t is equal to 0 and 4.9 t is equal to 7. So t is equal to 7 over 7 0.7s, which is 4.9, so that works out to be 10 over 7. So there's 10 0.7s in the top and there's 7 in the bottom, so yeah, t is equal to 10 over 7, and then s of x, the displacement in x, the range, is equal to ut, no acceleration, and my initial velocity in x is 14, so 14 by 10 over 7 is going to be 2/10, which is 20 meters. Question 2. A particle is projected with speed 35 meters per second. Not 7√5, 35 meters per second at an angle theta to the horizontal, and tan theta is 3 over 4. So before we read on, let's just put our theta in. O over a, this gives me a 5, so cos theta is equal to 4 over 5 and sine theta is equal to 3 over 5. Write the initial velocity in the form ai plus bj and find its speed, and you're told the magnitude of its velocity when it's 10 meters off the ground, corrected 2 decimal places. So if we look at the initial velocity first, u cos theta times I plus u sine theta times j, we're going to get the initial velocity to be 35 by 4 over 5 times I plus 35 times 3 over 5 times j. So the initial velocity is 7 4's, which is 28, and 7 3's, which is 21. So we need the speed when it's 10 meters above the ground. So this is my displacement in y is 10. So if we write the displacement in y and let it equal 10, displacement in y from ut plus a half at squared is going to be my 21 times t minus 4.9 by t squared, and this would have to be equal to 10. So we have 4.9 t squared minus 21t plus 10 is equal to 0. Does this factorize? I don't think it does. So into the minus b formula. You always try maybe to factorize it first. I've tried to factorize it. Doesn't seem to factorize for me. Maybe you can factorize it. So just typing this into a calculator, really, we're going to get two values. So we are going to get two values. Now we will get, why are we going to get two values? So if we fire this up here, you can see if this is 10 meters, there's 2 times when it's 10. So we want when it's 10 meters off the ground. Looking at the question, it doesn't tell us whether it's on the way up or the way down, so we will do it on the way up. So I've gotten two values here for t, and you can just type this straight into your calculator and then just go back and get the plus and minus version of the answer. So there's the first one is 5.546 seconds, and the second value, if we type that into our calculator, is 3.74 seconds. So if we look at we have 28 for I, that's not going to change. So my velocity at 10 meters off the ground is going to be 28 I plus. So for my y, we're going to have the u plus at. So the velocity of y is going to be the initial 21 minus 9.8 times that, 0.546, and divvying that into a calculator, we're going to get the velocity of the y at 10 meters at 15.65. we round it off, 15.65, so 15.65 in the j direction. So the magnitude, we're asked for the speed, the magnitude of this velocity is going to be the square root of 28 squared plus 15.65 squared, and they ask for 2 decimal places here, up here. So again, just calculator use. The magnitude of the velocity is going to give me 32.08 meters per second. In question 3, we're asked to find the range or of a projectile whose initial velocity is 10I plus 7j. So we know that the range, we need to get this distance here, the displacement the next, but we need the time taken to get there. So let's try and find the time taken to get there. And s of I is equal to ut plus a half at squared. So s of y is equal to this initial u, 7t, minus the half a, which is 4.9t squared. That has to be equal to 0. So 7t minus 4.9t squared equals 0. So I could take t out, which would leave 7 minus 4.9t equals 0. So this is we could divide by 4.9 if you wanted, but I think you can do it this way as well. So 4.9t is equal to 7. So t is equal to 7 over 4.9, which you've already seen. There's 10 0.7s in the top and 7 of them on the bottom. So time is equal to 10 over 7. So the range, coming over to the left, this s of x is equal to ut, which is this 10 times time, 10 by 10 over 7, which is equal to 100 over 7 meters. Dealing with meters per second here, meters. So that's equal to r, the range. So we're asked, what is the height and the horizontal displacement is 3/4 of the range? Well, here's my range. Let's get 3/4 of it. 100 over 7 by 3/4 is going to be 75 over 7. So the 75 over 7 is my s of x. So s of x, which is equal to ut, is equal to 75 over 7. And we have u is 10. So the time taken to get 3/4 is 10t, is 75 over 7. So 70t is equal to 75, so t is equal to 75 over 70, which 5 divides in 15 over 14. So that's the time taken to get to 3/4 of the range. We want s of y at this time. So here, the displacement in y is equal to, the u in y was 7 again, wasn't it? And we have it up here, 7t minus 4.9t squared. So s of y, I'll just do a bigger s of y, 7t minus 4.9t squared, which is 7 by 15 over 14 minus 4.9 by 15 over 14 to be squared. And if we type this into a calculator, we're going to get s of y to be the height above the ground, 1.875 meters. So that's the first 3 questions. That's all I'll do in this video, so they're not too long. So check out the next video for the next few questions from exercise 3B.